The AI project that we've done with Schneider, the aim was to improve both the single line to ground performance as well as the multi-phase performance. The early results are very promising. The old physics-based model, it was almost always wrong for the multi-phase faults. The AI model increased accuracy to the point where it's actually useful for the people who are trying to find the faults.
Welcome to the AI and Scale podcast. This is a show that invites AI practitioners and AI experts to share their experiences, challenges, and AI success stories. These conversations will provide answers to your questions. How do I implement AI successfully and sustainably? How do I make a real impact with AI? Our podcast features real AI solutions and innovations, all of them ready for you to harness, and offer a sneak peek into the future. Welcome back to AI at Scale podcast. My name is Gosia Gorska and today I'm hosting Alexander Chia. Alex graduated from Stevens Institute of Technology with a bachelor's degree in mechanical engineering. He also holds an MBA in finance from Rutgers University. Alex has worked for the United States Army as a civilian engineer, testing computer and communications equipment under extreme environmental conditions. His current role with Con Edison Power Quality Group involves pioneering new technologies and methods to ensure reliable power within New York City's 5 boroughs. So I'm very pleased to welcome you today, Alex.
Oh, thank you for having me.
I was wondering if you could tell us at the beginning a little bit more about Con Edison, your role in the company and current projects you are leading, because it is really interesting.
Oh, thank you. Sure. Yeah, so Con Edison is the utility company for much of New York City. By utility company, I mean we deliver electricity, natural gas, and in some areas steam to the customers that need them. You know, I know if you think about New York City, a lot of people consider Times Square, the Empire State Building, things like that. But New York City is actually a very large area. It's over 600 square miles and has over 14 million population, and that includes Manhattan, which a lot of people are familiar with, but it also includes the Bronx and Westchester. Brooklyn, Queens, and also Staten Island.
Okay.
And to cover that area, I work on the electrical side of things. There are 62 area substations that supply load to this New York City area. And for those keeping track, the voltage levels that we provide are 13 kV, 27 kV, and 33 kV. So.
And what is your role in the company?
So I'm part of a team that provides a couple of things. One of our main goals is to help large customers out with their power quality issues, which means that if they have issues with the way their equipment runs, or they're getting strange voltage levels at their service, we'll work with that. Another thing that my group deals with is locating faults on our medium voltage feeder system. And basically what that means in simpler terms is those area substations I mentioned before, they operate at a higher voltage level than, say, the low voltage grid that a lot of people think about when they consider the electricity that's being delivered. In Manhattan, it's 120, 208 volts, the low voltage grid. So in order to get the power from that electrical substation to the low voltage grid, it has to flow through these medium voltage feeders, then through a transformer, and then to the low voltage grid. So my group helps locate faults along that pathway.
And it all happens underground?
Depending on the area you are in New York City, the majority of it can be underground. We do actually have a lot of overhead, though, especially in the outer boroughs. Manhattan is all underground in terms of electricity. And I think you can see this picture that I included here. In the late 1800s, there was a lot of utility lines, telegraph, power lines that were above ground. And because of a series of events, one of them being the blizzard of 1888. There was a big push to
Hmm.
put everything underground. So that's how you have the system we have now, where in many parts of the city, not all, but in many parts, you have underground utilities that include the electricity, gas, and steam. Yeah.
Yeah, so for our listeners, we are actually looking with Alex at the picture that is showing New York City from 1890. And it is basically covered with the wires that are basically covering the whole sky. So it doesn't look very well indeed, and I wouldn't question the fact that it's all underground. But I imagine that in this case, looking for any faults in the systems is quite challenging. And as we all know, it's so hard for us to live without power. Like the heating systems, the water heating systems depend on the power. Our mobile, all of the electrical devices that we are using every day, this is like the crucial part of our lives. So, can you describe why locating underground faults is especially challenging? What happens if it occurs during the peak season, and how can we use AI in this situation? Is it any sort of help in this situation?
Yes, sure. So putting infrastructure underground helps protect it, from weather damage and other physical damage. But the problem is when something is underground and you have something fail on that system, you have to first you have to find the failure, the point of failure, and two, you have to excavate, dig, and repair it. So the first part of that, finding the failure, is extremely important. And in the past, it has been time consuming. Nowadays, a little bit less so in terms of the feeders, the medium voltage feeders I was mentioning. And the risk of not finding a fault and restoring that feeder in a peak season, like say here at Con Edison, it's June, July,
Mm-hmm.
and August is a peak season. If you don't make repairs in a timely manner, it can put the low voltage grid in that area in a very stressed state. It can sustain damage that takes weeks or months to repair.
Mm-hmm. Mm-hmm.
So you really want to address the faults that we've spoken about as quickly as possible. Yeah.
Yeah, like weeks or months, this is hard to imagine. And what are the limitations of the existing models? Usually, like I understand in the past, we were using physics based equations and models in this context. You were looking for some innovation, you were looking for a new, improved method for locating these underground faults. What have you discovered?
Yes. So, like you mentioned, the traditional way of estimating where these faults are is based on solid physics based equations, and that is generally given good results for a certain type of fault known as a single line to ground fault, which means, for the listeners who are not familiar, power is delivered in three phases. And
Mm-hmm.
if one of those phases makes contact with ground through like internal failure, that is a situation called single line to ground fault. And the traditional equations we've used in that instance, they've done well, but the equations haven't, the models and equations we're using have not done well on our system with um, multi-phase faults, which would be two-phase or three-phase faults. So the AI project that we've done with Schneider has the aim was to improve both the single line to ground performance as well as the multi-phase performance. And yeah, it's the early results are very promising. They address some of the shortcomings that the traditional model has.
Mm-hmm. And what's the role of AI in this situation? Is it helping you to predict where the fault is occurring? or you're rather analyzing the past occurrences and you try to detect where actually there is some fault happening right now?
So that's a very good point. I mean, the way we're using the AI model right now is it's taking past fault data and it's using that data to build a prediction of where a fault has occurred. But it's important to realize it's after a fault has occurred. We're not doing prediction in terms of like where something might happen. This is after the fact, but
Hmm.
it has shown that uh, the AI model, is able to more accurately determine where a fault is, a single line to ground fault is. I think it was a single percentage margin, which is good.
Hmm.
But also, the really exciting thing is that the AI model produced much more accurate results for the multi-phase faults, the two-phase faults we focused on. So the old physics-based model, it was almost always wrong, and by
Okay.
a large margin. Yes,
Okay.
yeah. The AI model increased accuracy, but like to the point where it's actually useful for the people who are trying to find the faults, the crews that go out.
Hmm.
And what that tells us is that we believe that there's something that we're missing in the multi-phase model. The fact that we were not able to come up with a good fault location before, and then with the same amount of information, this AI model was able to come back with something that was so much more useful, like indicates to me that there's something that we're not seeing in our traditional model, and this just shows that there's something else there that we don't know. So it's very interesting.
Yeah, that's amazing. So it sounds like it was quite easy to go from the past situation to the current one, where you have the model and the accuracy is much better. But I imagine that it took some effort and some time to develop the model. So it would be interesting if you could walk us through some of the phases of preparation, or maybe tell us what was key to succeed and to have this high accuracy model.
Sure, sure. So in my experience with this project, and also we had a previous project that dealt with AI predictions as well. One of the main difficulties in getting a functional model is really having good, clean data that's available for the team, the AI team to use. Con Edison has been around for, we just celebrated our 200th anniversary. So over the
Hmm.
years, there have been many different systems to track many different things, like where fault has occurred is one system, where the crews have gone out and fixed them. Another system, which my group is intimately familiar with and controls, is the oscillography that's used in these fault calculations. So my group has these power quality monitors all around the system, and when a fault happens, the traces, electricity traces, voltage and current, that data is in another system. So when it came time for the Schneider team to use all of these things in a model, in an AI model, it was a heavy lift to get everything from where it resided in its home to where it needs to be in a model. So just getting good, clean data and knowing where to find it and getting permission to use it was one of the biggest obstacles to getting the model to where it is today.
I see. I imagine that as a utility, you are very sensitive on the security of data. So, was there any particular approaches taken, or was it actually maybe slowing down the project that some of additional standards had to be maintained in order to build the model?
Yes, yes. I mean, as utility, we take our customer data and infrastructure data like very seriously, and there is a vetting process through the proper channels, which include cybersecurity and other teams that will say, hey, it's okay to use this data or it's not okay to use this data. And so we went through that process that took 2 or 3 weeks. It was actually smoother than I thought it would be.
Hmm.
But, I can see that in future projects where we include more data, maybe from smart meters or, including other metadata, it's going to be a bigger problem to make sure that privacy is respected and that things are being controlled in the proper manner. I've the kind of questions I've been fielding from different people. I've included who's looking at this data when the model's being created. Where is the data being moved to in terms of like cloud servers? Like, are the cloud servers in the United States? Are they in Europe? Are they somewhere else? A lot of questions, but necessary.
Yeah, and I'm so grateful that you bring this up because judging from the headlines in the press and some of the advertisement, you can think that it should be so easy and quick to get results. While if you want to do it in a secure way and in a responsible way, it's good to stop for a moment and ask all these questions that you just mentioned. And I'm so glad that you, as a company, you decided to follow this, as you said, it was a surprise that it took you not so much time, but anyway, you have dedicated time to ask these questions and to solve all the questions around the data security and the privacy. So I think it's a very important remark for everyone who is listening and thinking about deploying AI projects. Now, I wanted to ask you a more personal question. What was your approach to AI in this situation and overall? Is the AI hype helping or detracting organizations from using it? And what's your like personal take on it? Were you open, you personally, and also the organization, to try out the AI technology and see if it can bring better results? Or was there a lot of hesitation and, overhype feeling?
Yes, well, luckily, just by chance, I'd done, some personal projects that had given me a tiny, tiny bit of background in AI, even before, the current, 1 or 2 years where it's really gained some traction in the media. So I was a little bit familiar with AI, and, when people think about AI nowadays, they tend to consider the generative type of AI where you use Chat GPT and you ask it a question and it comes back with like a one-page answer and it's amazing. Or like you go to the movies and you see one of your favorite actors and they're old in real life, but they look much younger in certain movie scenes. But I think generative AI it has a lot of hype with it, and
Hmm.
I ran up against that trying to have this project come off the ground because people are very questioning, like, hey, is this real? And then I hear about hallucination, I hear about all these problems, and I think they're failing to make this distinction between the generative AI and the more traditional AI methods, which they've been vetted mathematically and they have a sound base, and it's been used for years in recommendation systems on YouTube, Netflix. If you listen to your favorite podcast, it'll make recommendations for you based on what you've listened to before. So hopefully in the next couple of years we'll see more acceptance and experience, which will give people a better understanding of what is possible, what is not possible, and what's already been done and already vetted. So
Yeah, that's a great reply. And for anybody who is listening, what would be your advice to start with this technology?
I would say my advice would be to start small and also to ask yourself really what your goals are, even before you start looking into AI, because if you have a problem, there are many different ways to solve it, but AI, you have to decide what you need to use in terms of, do you want to use generative AI? Do you want to use one of the more traditional methods? And you have to kind of be an informed consumer in terms of like what is possible and what is not. So,
Mm-hmm. Yeah, that's a really great advice. Okay, thank you so much, Alex, for the conversation. I still think about, what's happening underground in New York City, and the fact that you can actually go with this model and detect any kind of faults. It's something that makes me feel like it's really like a challenge that you are facing, and it's so good that we can find methods to solve it better and to ensure that everyone has access to power. So thank you so much for being with us today and for sharing the story.
oh, you're very welcome.
Thanks for joining us today on AI at Scale podcast. Be sure to visit our se.com/AI website and learn more about our AI at Scale solutions. Head over to our Schneider blog platform to read more. Don't forget to subscribe to the show on your preferred platform and share it with your network. Thank you for listening and stay tuned for the next episode.